Hi everyone, this is Mr. Campagna. Today we're going to talk about calculating the energy in electron volts of electron transitions. As you can tell, we have a bright line spectrum or emission spectrum of hydrogen here, and it's a very obvious fingerprint once you've seen this a few times. You could see here this 656.1 nanometer red line. It kind of stands out to me. Now, what we're going to do today is we're going to calculate the amount of energy required to generate these wavelengths. Today's lesson objective, we're going to calculate the energy in electron volt of electron transitions. So this probably looks familiar to you. This is the energy level diagram for hydrogen that was pulled from the physics reference tables. So you have a couple questions here which are pretty simple. You can answer those. And I want to bring you back to the dorm room analogy. So think back to our previous lesson where we had the analogy about a college dorm and student athletes. So the agreement was that the students would pay more to live on a lower floor so they didn't have to bring their equipment back and forth so much and carry it up flights of stairs. So what you need to keep in mind is the higher the floor that you're on, the less money you would pay. So somebody that's on, let's say, the 6th floor here pays 38 cents. Now remember, they're paying it. That's why the number is negative here. Somebody that was on the 5th floor would pay 54 cents. 4th floor, 85, and so on until you get to the ground floor, or floor 1, where they're paying $13.60. Now, the other thing you want to keep in mind is that the students can change rooms. So somebody that is on floor 6 can jump all the way down to floor 1. So to make that move to go from floor 6 down to the ground floor, they now need to pay $13.22 to make up the difference. That's what they need to pay out. So now think. How does the ground state of hydrogen relate to the ground floor of a building? All right, so hydrogen emission spectrum. 1. Each arrow has been labeled with a letter A, B, C, D, E, or F. Fill in the box on the right with the appropriate letter. So we got to figure out which letters go here. 2. Calculate the energy in electron volts for each electron transition. Remember the formula. Initial minus final equals the photon energy. This is written in your reference table as E photon equals EI minus EF. Now remember, we're going to be subtracting negative numbers here, and that's going to give us a positive. So our first one, we're going from N4 to 1. So level 4 down to level 1. Think of it again like that analogy where you're going from the 4th floor down to the 1st floor. So our first step is to figure out which letter, which arrow are we looking at here. So we're going from N4 to 1. So if we're going from 4 to 1, it's going to be this guy right here, which is labeled as letter A. Now we need to figure out what the energy levels in electron volts are emitted. So we really need to use the formula initial minus final equals photon energy. So our initial is negative 0.85. We're going to now subtract away, it says here, subtract our final number, which would be 13.6, because it's dropping from level 4 down to level 1. So negative 0.85 minus negative 13.6 gives us 12.75 electron volts. Let's do the second one. So if you can see here, it says from 4 down to 3. And if we look on here, we could see here's level 4, here's level 3. So we're looking at arrow B. And then we need to determine the energy levels. Well, we're starting from the same spot. So our initial is still negative 0.85 as shown here because it's starting at that top level. Now we have to subtract away, as per the formula, where it's going to. So it's dropping from level 4 down to level 3, which is listed as negative 1.51 electron volts. So we're going to subtract out negative 1.51, giving us 0.66 electron volts. So that's pretty much it. The formula is relatively simple as long as you remember it's going to be a negative, take away a negative, giving you that positive amount to see just how much those electron transitions give up in energy. So I hope this has been helpful. Thanks for watching.